Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have completed as a chapter number 2. The name of that chapter is a retrosynthetic analysis, and that is a new chapter introduced at T.Y.B.Sc level. What are the important terminology or what are the important term involved, its definition, and with their suitable example we have explained each and every point with the help of their application as well as their definition and the meaning, what are the arrows, what are the essential point required for it. We have discussed everything, as well as we have discussed what are the probable questions they are going to appear in the exam. So that type of the question we already discussed. So today what we are going to discuss, look at here on the blackboards. Now there is a written chapter number 3. The name of the chapter is a rearrangement reaction. First of all, we will talk about the introduction of the rearrangement reaction. First, let me tell you the definition of rearrangement reaction. A reaction in which the carbon skeleton or the functional group or both are modified is known as rearrangement reaction. Rearrangement reaction means we have already familiar with the organic compound, and that organic compound containing so many atoms, how their orientation in the spatial, how they are arranged, even though very small molecules are there, but their arrangement of that atom in the spatials are different, and therefore how they get rearranged, and that type of the thing is known as a rearrangement reaction. And there are so many reactions we have learned, but this is a different type of the reaction like that. There are mainly five type of the organic reaction. We know that number 1 is called as a substitution reaction. Substitution reaction means a reaction in which one of the atom or group of atom get replaced by the one atom or the group of atom by the reagent used is known as a substitution reaction. And the second type of the reaction we have learned, there is a elimination reaction. And elimination reaction means what? A reaction in which atom or group of atom are removed from the reactant or from the substrate and form the product with higher degree of unsaturation is known as elimination reaction. So that is the second type of the reaction. And third reaction, we know that there is a addition reaction, right? And what do you mean by the addition reaction? A reaction in which atom or group of atom is get added across the carbon-carbon double bond or the multiple bond, and resulting into as a single adduct, or what we can call it as all the reagent get consumed together and form as a product. That type of the reaction is known as addition reaction. That also we have learned. And then fourth type of the reaction is let us see, before that is a redox reaction. Redox reaction means what? There is a oxidizing and reducing reagent. While using that word, whatever result is obtained, product is obtained, that kind of the reaction is called as a redox reaction, means oxidation reduction reaction. They are belonging to that redox reaction. And the last one, fifth one, is known as a rearrangement reaction. The rearrangement, just now I told you that the definition of the rearrangement reaction, a reaction in which the carbon skeleton or the functional group or both are modified, is known as rearrangement reaction. So this is all about the rearrangement reaction, and it is based on it is a broad class of organic compound or organic reaction where the carbon skeleton of molecule is rearranged to give a structural isomer of the original molecule. Often a substituent is moved from one atom to the another atom in the same molecule. In the following example, substituent R moves from one carbon atom C1 to the carbon atom 2 C2. This is an example of intermolecular rearrangement reaction. Let us see here how the simplest example is shown over here. Here is I am placing R, then there are 3 carbon atoms are there. Let us see 1, 2 and 3, and now this is a carbon skeleton, and that carbon skeleton has, suppose as this type of the R group is there, and this R group may shifting at 1, 2 position from this to this. What you are going to get there? You are going to get here C are at this position. So here 1, 2 and 3 carbon atom. If you observe this reaction carefully, what do you see? In a first case, here in the starting compound, the R group is attached to at carbon number 1. After migrating, if you see the product, the R group, R substitute migrate from carbon number 1 to carbon number 2. It is rearrange itself, and we are getting such a type of the shifting occur automatically in the molecule. So that type of the reaction is called as intermolecular rearrangement reaction, and these are few example of intermolecular rearrangement reported in the literature. Let me tell you, these are the few example of intermolecular rearrangement reported in the literature. We have in a chemistry vast kind of the literatures are available, but few of them such a type of the rearrangement reaction are reported in a literature. So you can get the lot of information if you search in that literature. And some of the rearrangement reaction are well represented by simple and discrete electron transfer, but few cannot be well represented by it. And the actual mechanism of alkyl group moving probably involve transfer of the moving alkyl group fluidly along a bond, and not ionic bond breaking and forming. In pericyclic reaction, mechanism can be explained by orbital interaction, and which give a better picture than simple discrete electron transfer, while some reaction involves ions. And as we know that there are the different kind of the mechanism, as I already told you, mechanism is nothing but the detailed study of sequence of steps which are involved in the conversion of reactant into product is known as mechanism, and there are mainly two kind of the mechanisms are involved. One is called as a mechanism, ionic mechanism, and second one is a free radical mechanism. All the ionic mechanism we know that by generating positive and negative or developing minus delta charge or plus delta charge, that type of the induced polarization is developed due to the heteroatom compound present in the hydrocarbon. And as we know that hydrocarbon means what? The organic compound made up of by carbon and hydrogen is known as a hydrocarbon, and they are non-polar in nature. Why they are non-polar in nature? Because the carbon atom and the hydrogen atom both are having their electronegativity approximately same, and due to that reason the hydrocarbons are what we can call it as a non-polar in nature. And if the heteroatoms are involved in the organic chemistry, apart from that hydrogen and carbon, some of the other elements occasionally occurring in the organic compound, like as oxygen atom, nitrogen atom, sulfur atom and halogen atoms, and when they are present then there is a polarization induced. The molecule get polarized, means there is a difference in the electronegativity occur, and that's why the bond, that covalent bond get polarized, so develop plus delta charge or minus delta charge. So whenever there is a more electronegative atom, and as we know that all the heteroatom, for example carbon, nitrogen, oxygen or halogen, all are more electronegative than the carbon atom, and therefore whenever such kind of the atoms are present, they shows as a magnetic moment, or they are polar in nature. So that type of the inducing the polarization in that molecule, and that's why they. Now let us look at this is general introduction regarding as a rearrangement reaction. Moving toward as the next point, the next point we are going to discuss over here, types of rearrangement reaction. Next point after the introduction, we are going to learn types of rearrangement reaction. Types of rearrangement reaction. Types of rearrangement reaction. There are number of generally 3 key rearrangement reactions are. How many types of rearrangement reactions are there? There are 3 key rearrangements. Key rearrangement. Number 1, which is known as first one, which is known as a 1-2 rearrangement reaction. This is known as a 1-2 rearrangement reaction. 1-2 rearrangement reaction. This is the first key rearrangement reaction. Is nothing but as the first one. 1-2 means 1-2 indicate as a relative position of that particular substituent when they are migrating from 1 to 2 positions. So that type of the reaction is belonging to as a 1-2 rearrangement reaction, because the rearrangement means the atom they get oriented in a space in a beautiful manner, and we are getting the what we can call it as a desired product. So that type of the concept, that type of the one key reaction is known as a 1-2 rearrangement reaction. And second one is known as a pericyclic reaction. Second one is known as a pericyclic reaction. This Second one is a pericyclic reaction. And pericyclic reaction, it is one of the kind of the reaction the electrons are moving in a cyclic manner, and there is a cyclic transition state is formed, and when there is a carbon-carbon double bond or single bond, they are alternatively go on breaking in a cyclic manner, and we are getting the formation of the product, and that type of the reaction, pericyclic reaction, are a concerted reaction. Concerted reaction means what? Whenever there is a reactant converted into as a product, means at that moment there is a formation of the bond as well as breaking of the bond. These two processes are simultaneously taking place. So such kind of the reaction are known as concerted reaction, and this pericyclic reaction, the mechanism is proceeding through that concerted type of the mechanisms are there. So that type of the reaction, pericyclic reaction, are cyclic, moving of electron are cyclic in manner, so that it is called as a pericyclic reaction, and they are certainly occur at room temperature in a thermal condition, as well as some of the reaction taking place in a photochemical, means under the sunlight. So these are the two main type of the reagent, we can call it. Either the pericyclic reactions are occur at room temperature, means it at thermal position, or we can call it is carrying out, taking place under the sunlight, means photochemical type of the reactions are there. So that type of the reaction is called as a pericyclic reaction. There are number of types of there are pericyclic, electrocyclic reaction, cycloaddition reaction, then so that kind of the reactions are there. Now we are talking only the specifically key rearrangement reaction, and the third one is known as the olefin metathesis. The third one is known as a olefin metathesis. Third one is known as a olefin metathesis. Olefin, not O-L-E-F-I. Olefin metathesis. Olefin metathesis. This is the third kind of the reactions are there. So these are the three key rearrangement reactions occur in the organic chemistry. So other important reactions are just like as a Beckmann rearrangement, Baeyer-Villiger oxidation reaction, Pinacol-Pinacolan rearrangement reaction, Curtius rearrangement reaction, Favorsky rearrangement reaction, Claisen rearrangement reaction, photochemical reaction, and the thermal rearrangement. So these are the other rearrangement which are very, very famous reaction, so that we have seen there are some of the what we can call it as a famous rearrangement reaction, and which are we are going to learn these reaction step by step, or in this particular chapter only. Here just I am giving what type of the named reaction we are going to learn in this chapter. So that is under the heading of types of rearrangement reaction, and these rearrangement reaction have industrial application, and mainly whatever rearrangement reaction we have I have named here what are the application of that rearrangement reaction, why we are learning these rearrangement reaction, what is the purpose behind it, and that's why the industrial they are having as a great industrial application of these every and each rearrangement reaction have their application in the industries, because mainly industries are working on that chemical industries mainly, and in what field. So that why these are industrial application that we are going to, in what industrial application in plastic. We know that everywhere you can see the plastics are there, because when the scientists, chemists discovered that plastic, and plastics nowadays is very useful in many ways, their utility, their application of that plastic. But nowadays this also, when there is a lot of application of that plastic, similarly as far as the environment pollution is concerned, now the majority of the pollution is due to the plastic, because that plastic is nowadays is a very that plastic is not what we can call it as is not get degradable. It live in the environment for longer time, and therefore the major problem is generated due to the plastic. But as on the other hand, if you see its application in every field, in a saline or whatever the food materials we are preserving or we are carrying that bag, and so there are so many applications of their number of bags, or they are replacing all the utensil whatever we are using in our day-to-day life. So all are applications of that plastic. But in addition to that, after using that plastic we are throwing, and that making as a very, very serious problem that globally that environmental problem is facing nowadays. At that time who he discovered, he got the Nobel Prize at that time, but now most of the scientists are trying to find out how we can degrade, how we can find the solution to degrade that plastic. So that is one of the major problem, but we are talking about that applications of that industrial application of that plastic. And second one is of polymers, right? And polymers also has many application. By using as a polymer whatever utensil we are using, which is made up of by that polymer, again polymers, it has a vast application, as well as it also creating after the use whatever after some days or some year they becomes as a what we can call it as a damages, and that create the pollution. So that everyone has that one. And then pharma means what? Pharmaceutical industries. And now whatever now we are facing the great problem, that is what we can call it as the global pandemic COVID-19 nowadays we are facing. So the pharmaceutical chemistry is trying to develop that vaccine, or what we can call it as a medicine on it. But nowadays the vaccine may come here, but whatever pharmaceutical industries are there. They are synthesizing that particular drug or whatever medicines are preparing, and during that preparation, and they are using how volatile solvent, or what we can call it as a number of side products are generated, and that useful desired product or pharmaceutical fine chemicals obtained after doing lot of steps are involved, and during that step whatever the side products are obtained, whatever the gases are evolved during that process, they are making serious problem for water pollution, air pollution, or dumping in the soil. So they are making as a soil pollution also. So that there are some guidelines are there for World Health Organization that following norms nowadays, but the major problem they are generating, so that is mainly as a pharmaceutical chemical most of the, but we are alive here. We can because in every tablet that particularly that is beneficial than whatever they are polluting. So that's why they are the very essential or the useful over there. The next one is the dyes. In a dyes also we are using this type of the rearrangement reactions are involved. The next one is paints, different paints we are using, that is also made up of that chemicals, and some common rearrangement reactions are given below, and that rearrangement reaction we are going to learn one by one. Here the first one is a 1,2 rearrangement reaction, and 1,2 rearrangement reaction, first reaction we are going to learn, that is nothing but as a Wagner-Merwin rearrangement via non-classical carbocation. What do you mean by the non-classical carbocation? And there are certain rearrangement reactions. So I think that we will see in the next time. So this is the introductory part type of the rearrangement reaction. We have talked a lot about that one. I think with this let us stop today here. Remaining we will see the next time. Thank you. Have a nice day.